Hi, MC Bling Daddy here, and welcome back to another segment in our continuing series on how to use command blocks as one might would a high-level programming language such as C# or Java. And today what we're going to take a look at is what's called a switch. Now, in order to do that, in order to accomplish a switch between different modes of operation, we need a variable that will hold the information about which version we want to use. So let's take a look at our first command that we will execute typically, and that is to set a variable on our scoreboard to a value, in this case 2, and what 2 will signify is that we are going to add an extension to our railway in the positive x direction. But now there is one thing we have to do before we can actually manipulate the variable, and that is to create it. So let's go back one step and set things up here with the addition of our add variable to the scoreboard objectives. And notice that we have two things that we call add. One is the action to add the objective, or as we are calling it, the variable. And the other, which might be confusing, is the variable or objective itself, which is also called add. But notice that there is a capital A in add for the name of the objective, whereas our verb, if you will, to add the objective is lowercase a. And as typical for the execution of our code, we call or we use the type of variable or objective. We call it dummy. So, and that simply means that it is not going to actually use anything like kills or distance or anything like that as the value that's placed into our variable add, but we are just going to manipulate it within the code itself. Okay, so let's add that objective in, and then we should be set to go for our manipulation of the objective. Now let's take a look at what we do with that, what we do with our variable add. And you'll remember that we have a loop that cycles through a series of additions to the railway, extending it one position at a time. And what we've done is we've added in at the end, rather than jumping to the part of our code that will execute the addition. We have skipped that. We go back one step where we actually indicate how many times we have gone through the loop. And rather than jumping to the next place directly, what we do is we have a series of tests. So the first test is for the score that we have called add, and we are testing to see, first of all, if there is a score that is called add, and whether there is a score that has a value that is at most 1. That is what the equals sign indicates here, is actually less than or equal to. But at the same time, we are also testing for the same variable, but we are testing to see if that variable has a minimum value of 1. And so the only way that that can happen is if it's exactly equal to 1. It has to be less than or equal to 1, but it also has to be greater than or equal to 1. That can only happen when the score is 1. Now let's see what happens with that. That's a testfor. And what we have beside the testfor here is a comparator. And so what happens when the testfor succeeds, we will then set the comparator. Remember that it remains on until something actively turns it off, so that as the signals come through here, the command block that I'm directly over will go on and then it will go off. But if it sets the comparator on, the comparator will remain on. So as a consequence, we have to have something that I hope you remember you've seen before, which is basically an AND, which takes the signals from both the testfor command block and the empty block here. You see there's no command in it, which simply turns the direction of the signal and feeds into a circuit, part of the circuit, which is an AND. And when the comparator goes on, what will happen is that it will activate the dirt block, which will turn off the torch. And what will happen is that the pulse from the command block will feed through to this torch, and when they are both off, this torch will go on and feed the signal through. And if I can get through the sheep here, we will see that what happens then is when our add variable is 1, we will transfer control to our segment of code that we call add z. And that is right here. So that's what happens when add is 1. We have another testfor that executes simultaneously. In this case, the testfor tests for a value of 2. If, in fact, our add variable is 2, it can only equal 2 for this test to succeed, then we have another comparator, another AND circuit, and what will happen is that we will then execute a transfer of control to our add x code segment. And then finally, we have another testfor, which is to test for a value of 3. And the same thing will happen if the value is 3. Now notice, we've only tested for 3 different values. If the value is something else, our testfors will fail. And if our variable is 0, or if our variable is greater than 3, none of these tests will succeed and will also fail. So the testfor, in this particular case, can potentially miss a lot of values. And in addition, a comment that I need to make is that you have to be very careful when you do this kind of thing, when you use a switch like this, that each one of your tests is mutually exclusive. There is no code checker for you to test to see if any of these things will go off simultaneously. So you need to verify that yourself. However, there is also the potential that maybe you would like to have do more than one thing go simultaneously. So you can adjust these tests to do that. But again, you have to be very careful about what you're doing and making sure that things do not overlap. So let's go take a look now and see what we're going to do with this for right now. So our first execution will be with the value of add set to 2, which means we're going to extend in the x direction. And if you'll notice, let me see if I can get up here to take a look, our minecart has been placed back at the origin. Oops, looks like something messed up our minecart. That's one of the problems that you have. I had not anticipated this. So we'll go take a look here and see what we've got. And it looks like what we need to do is we need to put our minecart back on its original location. So let's see, that's with a test here for, no, not name. I'm getting too used to that. Type equals minecart rideable. And we're going to set it to 1 tilde, the same height as we are, 1. So should move it forward 1. There we go. Okay, now our minecart is back where we want it. Let's hope the sheep doesn't come and interfere again. And so what we will do then is we will set our loop up to add in the X direction. A couple of other things that we need to do though, and the first one is to reset our loop index. Every time you run through the loop index goes from the base value here of 0, actually before it's executed it's set to 1, and then a test is made for that to see if we're finished. So, but we need to reset that every time we run through the loop. And then, of course, our last thing to do will be to transfer control to the loop, and we do that by setting down a redstone torch, just to remind you of how we do that. Okay, so let's see what happens. Let's see if I can find the cursor here. And, okay, our minecart got moved 1 there. All right, let's go see what's happening with our execution. And you'll notice that, oh, are we already done? Well, yeah, it's done. Too bad. We'll see if we can set it up maybe for a longer execution then. All right, let's try this out again, but this time let's see if we can extend in the Z direction. Okay. And once we get started here, and we'll run up here and see if we can verify that our, aha, you notice the darkened torch there. Okay, and the lighted torch here. So let's see what happened. Oh. And what that means is that our variable was set to a value of 1. And so this loop, this testfor executed and set the comparator. And so we should have extended in the Z direction for a value of 1, and in fact, we have. All right, so extended X and Z, and then finally, let's go back and do one more thing, and that is to execute in the X and Z directions simultaneously. We'll do this. Start our execution. And let's see if we can get up there in time to see what's happening for a value of 3. Okay, notice that our comparator torch is darkened this time, and we are in the testfor score of 3. And we therefore passed execution on to the XZ direction, and let's go take a look and see where we are. And sure enough, we extended off in the XZ direction. Well, that's how a switch works. And so next time we'll take a look and see if we can extend our capabilities just a little bit further. And so that's it for now. Thanks for watching.